Hi everyone, welcome to lesson 3 of our trigonometry unit. Today's lesson we're going to be focusing on trigonometric ratios. So, first things first, we got to remember what the cast rule is. The cast rule is basically just a convention to remember where certain things are positive. We have a quadrant system here, and just to help you out, I'm going to start labeling this one as Q1, as in quadrant 1. Over here to the immediate left, quadrant 2. Quadrant 3 is just going to be down here. And quadrant 4. So now that you've labeled your quadrants, now we can superimpose onto the cast rule. So we have C, A, S, T. And this cast rule basically is only for your primary trig ratios. It's going to tell you where these certain trig ratios are going to be positive. In quadrant 1, A stands for all, so that means all trig ratios are going to be positive here. Sine is positive only in quadrant 2, tangent in quadrant 3, and cosine in quadrant 4. That also means if I was tangent in quadrant 2, I'm looking for a negative number, or if I was cosine in quadrant 2, I'm looking for a negative value. Right below we have our basics trig ratio, so sine, cos, tangent with all their sides. So sine opposite hypotenuse, cosine adjacent hypotenuse, tangent opposite adjacent. What we need to now do is figure out their reciprocals. The reciprocal of sine, and by the way reciprocal meaning 1 divided by, the reciprocal of sine is cosecant. It's just flipping around your opposite and hypotenuse side. The reciprocal of cosine is secant, and the reciprocal of tangent is cotangent. Quick note here, tangent is made up of either opposite adjacent or sine divided by cosine. Or we also have this note here that says cotangent is cos divided by sine. The reciprocal tangent ratios follow their related primary trig ratios when looking at the cast rule. So what does that mean? That means that wherever your primary trig ratios are positive, your reciprocals will also be positive there. If tangent's positive in quadrant 3, cotangent will be positive here. If cosine is positive here, secant will be positive here, and vice versa. Getting right into our examples, the first thing we want to look up is determine the exact value of the 6 trig ratios given this coordinate here. Well, what I would do is I would sketch out a rough draft of what this picture might look like on your grid. So if you had 5, negative 12, I'm just drawing my grid something like this, 5, negative 12 is going to look like this dot here. So if I'm 5 there, about negative 12 is going to be right down there. Drawing a line from my origin out. Let's color that properly. There we go. And what I want to do is always build a triangle, a right angle triangle right back to the x-axis there. So I'm just going to draw a line straight up to the x-axis. Start labeling your coordinate now. 5 is on the x, and this is, by the way, x comma y, of course, as an ordered pair. So 5 is on my x-axis, so I'm going to put 5 right there on my x-axis. Negative 12 on my y-axis, negative 12 is going to go right here. My hypotenuse side I do want to find out, so let's use Pythagoras' theorem. So that is the same thing as saying, let's call our hypotenuse side h. So I'm going 5 squared plus negative 12 squared equals h squared, h for hypotenuse that is. And here 5 squared plus 12 squared is 169, so you have 169 equals h squared, and h by itself, if you square root both sides, h is now equal to 13. Now that I have 13, let's figure out some of our ratios. And of course I'm just going to also fill in 13 in my equation over here. So let's write down our basic trig ratio. So we have sine theta, and sine theta of course is going to be opposite over hypotenuse. So opposite side is 5, have our hypotenuse side 13. Cos theta, and by the way, theta is going to be right in between here, our x-axis, and our hypotenuse. Cos theta is equal to adjacent, oh wait, the first one I was not right yet. I said opposite over hypotenuse there, so opposite was negative 12. Sorry, my apologies. Over 13. That's sine. Cos will be adjacent over hypotenuse, so that's the 5 over 13. And tangent, theta is going to be equal to opposite negative 12 over adjacent. There we go. So those are my primary trig ratios. So to write down my reciprocal trig ratios, so sine goes with cosecant, cos goes with secant, and tangent goes with cotangent. So if I have a fraction already, the reciprocal of it means just flip that fraction around. So I have a new fraction of 13/12 for cosecant, 13 over 5 for secant, and negative 5/12 for cotangent. There we go. In example 2, we have given that cos theta equals negative 7/8 and tangent has to be greater than 0, determine the exact value of sine. So we're looking for, on our quadrants, where this would exist. We're looking for somewhere where you have cos negative and you have a tangent that's positive. So let's double check our cast rule real quick. And let's jot down CAST. I know that my graph here is in multiple colors, but that's okay. We're looking for where cos is negative. Well, cos is negative only in either 2 or 3 here. So you're looking for either, for cos negative is either in 2, quadrant 2, or you're in quadrant 3 for cos negative. For tangent to be positive, you're looking in which quadrants? Well, tangent is positive in quadrant 1, because all things are positive in quadrant 1, and in 3 there. So what I want to look for is the quadrant that had the overlapping information. So right now we're looking at quadrant 3. So let's just quickly sketch out our quadrant 3 and sketch on negative 7/8. So again, it's just going to be a line. Let's draw a line straight to our x-axis to build that triangle. There we go. And let's denote where our angle is going to be. Theta is always right here between your x-axis and hypotenuse. So cosine uses adjacent and hypotenuse, so I know my hypotenuse side is going to be 8. My adjacent side has to be negative 7, and also why is it negative 7? We went to the left. We do want to find this y value here, and again, how would we find this? Let's use Pythagoras' theorem. Let's call this y, this missing side y. Okay. And to find y squared, of course, is equal to 8 squared minus negative 7 squared. And of course that's 64 minus 49, which is just 15. And square rooting both sides, we get y equals plus minus root 15. And don't forget that whenever you square root a variable, you're always going to have a radical that's plus minus. From here, we want to look up what sine is. So sine theta, sine of course is opposite over hypotenuse. Opposite side is now this radical. And out of this radical, we needed a negative radical. So y equals negative root 15. We can't be positive root 15 because this line here is going down, by the way. So we needed a negative root 15. So sine is our negative root 15, opposite side, over our hypotenuse side of 8. And there we go. So we have an answer of negative 15/8. Let me just clean that up and then we'll get going on number 3. In example 3, we have the angle in standard position with the terminal arm in quadrant 2. The terminal arm has a length of square root 29 and contains this point x and 5. Determine cotangent. So again, drawing out a quick sketch here. So I know this time that I'm in quadrant 2, so I'm just going to draw something in quadrant 2. So there we go, that's my grid more or less, and I know I'm in quadrant 2, that's going to be my line. Let's draw a line straight down to our x-axis there. There we go. And we know a few things in this question here. We know that the length of the arm here is square root 29, so I'm going to write square root 29 right here on that hypotenuse. There we go, that's my 9. We also know point P, which is this coordinate right here, this is P now, is made up of x and 5. Well, 5 is our y-axis, so y goes here. X here isn't just an x, it has to be negative x because we went to the left. So for this one here, let's find x first. So we're going to go x squared equals square root 29, all of that squared, minus 5, all squared. That's the same thing as saying 29 minus 25, which is just 4. So x has to equal the square root of 4, which is going to be 2. But we don't have just 2, it's going to be plus minus 2 because we square rooted a variable. From here though, we needed our negative x value, so therefore x has to equal just negative 2. And if you have that, we can figure out cotangent. So again, cotangent theta is the same thing as 1 divided by tangent theta. And of course, tangent uses opposite over adjacent, so let's just jot that down. So this is the same thing as saying 1 divided by opposite side of 5 divided by adjacent side negative 2. If you reciprocate and clean that up, that's now negative 2/5. And there we go. In our next example here, example 4, we have determined the exact values for the trig ratios given this set of coordinates here. So the first things first, we do want to try our best to do a quick sketch of this. So I have a negative and a positive value. So if I'm negative and positive, I'm in quadrant 2. So I'm just going to draw my grid there. I know it's in the wrong color, but that's okay. I'm going to draw my line off there in quadrant 2. And because we already used red in this case here, I'm just going to use blue. And again, line always going straight down to our x-axis. Let's label this here. So this is my x value, this is my y value, so x value is going to be negative 2/3. Y value here, root 5 over 3. Let's find our hypotenuse side, and again, how do you find hypotenuse? We're running Pythagoras, so we have root 5 over 3 squared plus minus 2 over 3 all squared, and that's going to equal h squared there, because that's our hypotenuse, so h squared is equal to, this is now going to be 5 over 9 plus 4 over 9, which is 9 over 9, which is just 1, and so then therefore square rooting both sides, h is only just going to equal 1, so 1 goes right here. So let's jot down our trig ratio. So first one, let's go for is sine theta. Sine theta is opposite root 5 over 3 over hypotenuse, opposite over hypotenuse, so our first one just root 5 over 3, then we'd be finished. Cos theta is adjacent over hypotenuse, so now we just have 2 over 3. Tangent theta, and I ran out a bit of space, I'm just going to move some of this over. Tangent theta, I'm just going to do in red just because it's a bit different. Tangent theta is opposite over adjacent, so this is going to be root 5 over 3, all of that's divided by negative 2 over 3. Well, if you clean this up, the 3's and 3's will cancel, and you're going to be left with negative root 5 over 2. And there we go. Our other trig ratios, the other 3, so if I have sine, I have cosecant is the first one. Cosecant theta, again just flip that around, that's 3 over root 5. We can never have a radical in a denominator, so we're going to work with the idea of rationalizing. So that means multiply top and bottom by that radical, gets it out of the bottom. So now I have 3 root 5 up top in my numerator. All of this is divided by just 5 there or all of that's divided by 5 denominator. There we go. So you have secant theta, and again just flipping that around, no real work there, just 3 halves. And cotangent theta is equal to, again flipped around, I got 2 over root 5. Again, rationalizing top and bottom, this is now negative 2 root 5, all divided by 5. There you go. Let's talk about unit circle. So this is a new idea here. So it basically is saying for a coordinate to be on the unit circle, you have to have a radius of 1. And that radius of 1 is now your hypotenuse, and it's always going to go around our quadrant here. So all we have to do is check if I gave you this random coordinate here, xy, is it on the unit circle? Well, how do you know? If you ran Pythagoras' theorem on this, and you have an answer of 1, then it's going to be on the unit circle. If you got an answer smaller or bigger than 1, it is not on the unit circle. So all we have to do, let's run Pythagoras' theorem on this ordered pair here. So I'm not going to even bother with rationalizing. I'm literally going to just set up my Pythagoras' theorem. So I have x squared plus my y squared, which is negative 1 over root 2 all squared, and we're hoping that's going to equal 1. So let's figure out what this equals. So this is here on the left, I have 1/2 plus another 1/2, and of course, yep, 1/2 plus 1/2 is equal to 1. So there we go. This is on the unit circle, is the point on the unit circle, therefore on unit circle. Example 6, if x value is already on the unit circle, what's the other y value? So all we're going to do is go 1 minus root 3 over 2 there, because we're just doing Pythagoras inverse, so it's going to be 1 squared minus root 3 over 2 squared equals that y squared there. So y squared is equal to 1 minus, that's going to be now 3 over 4, and of course that y squared is equal to 1 over 4, and square rooting this, you get y equals plus minus, because we square rooted a variable, that is plus minus 1/2, and there you go. Your coordinates, if you wrote them out, would be root 3 over 2 and positive 1/2. That's your first one, and your second one would be root 3 over 2 with a negative 1/2. There you go, 2 coordinates. Number 7 is find the x coordinate if the y coordinate was this guy here in quadrant 3. So by the way, in quadrant 3 everything is negative, all your x's and y's are negative, so let's just make sure that we get something negative. But let's find x though. So I have x squared equals 1 squared minusing off in bracket we have that negative root 5 over 3, there we go, all squared. So x squared here is equal to 1 really, minus, well, what is this? This is the same thing as 5 over 9. So I have 5/9, and if I subtract that, x squared there is equal to 4 over 9. And of course, if we square root both top and bottom, x is equal to 2 over 3. Positive and negative, because we square rooted a variable. But again, the note here is we have to be in quadrant 3, meaning everything has to be negative, therefore x has to only equal this negative 2 over 3. So our coordinate would be negative 2 over 3 comma negative root 5 over 3. And there we go, that's number 7. Last but not least, we have determined the point on the unit circle given that the terminal arm of the angle is in quadrant 3 and has this here, this coordinate of sine theta equals negative 1/4. So first off, if I'm in quadrant 3, I'm going to set up a picture here. So there's my x-axis, there's my y-axis going down, that's quadrant 3 down there. Let's draw a line to denote that we're in quadrant 3, drawing an arrow straight up to my x-axis. There we go, we built our triangle. Let's start labeling our triangle. Theta, of course, is always going to be between the x-axis and your hypotenuse line. Sine uses which two sides? Sine uses opposite over hypotenuse, so hypotenuse here has to be for opposite side, that negative 1, because we're going down. What we want to find is probably this x value here because we're still missing it. So let's work Pythagoras backwards to get it. So I have x squared is equal to 4 squared minus negative 1 squared there. And so that's 16 minus 1, which is just 15. And so x is equal to square root of 15. And again, I'm missing my plus minus. Don't forget that in front. Actually, let's do that in a different color so that it emphasizes that a little bit more. So we need plus minus in front of this radical. But if we're in quadrant 3 there, the only x value we need is negative root 15, or negative root 15. There we go. So this guy here, negative root 15. There we go. Determine the point on the unit circle. So to be on the unit circle, first off, I can't have a radius of 4. I need a radius of 1. So quick note again, just because we had this earlier. So to be on unit circle, need radius of 1. So currently right now we have radius of 4. So how do we get that to become 1? I'm going to divide all the numbers by my hypotenuse there. So I'm going to divide everything by 4. Divide by 4, divided by 4, and this is now divided by 4. Okay, so if I divide everything by 4, if I want to sketch out a new triangle, I'd have something that looks something like this. Negative 1/4, 1 goes right here, and negative root 15, all of that's divided by 4. So that's going to be my new coordinates, basically. So what's my determine the point? So this would be the point there, point P, let's just label it. So then point P would be equal to our x value, which is negative root 15 over 4, and our y value, which is negative 1 over 4. And there we go, that's our coordinate for this one. If you have any questions, please feel free to ask.